Assalamu alaikum dear viewers, welcome to our YouTube channel Design Experts. In this video we will study about the fail projects and how to remodify it and re-verify the project to pass. So if your structure member fail, what will you will do? So now let's start. Select the user save default settings. Okay, and the middle of this video we will also discuss about this, that how we save the settings from the model. So now just assume the lengths of the as well spacing. Number of stories is 2 and typical height of story 4.20 and 1.20 is from foundation to tie beam level. User default setting, that is the user save default setting, you can save here. Now the settings we were saved here. In this model we will use C1 and C1 column 1 and B1, while we reduce the size from standards to non-standard size like C1 200 by 200 and B1 200 by 300. That's why we want to see the structure failure of concrete member as well as shear force and bending moment diagram. You will under when you see the shear force and bending moment diagram of the fail objects, you will easily understand that how the fail diagram, the difference between fail and past diagrams. You will also observe the curves that and shear force limitations. So now select the B1, click on the mouse outside the grid line and drag them so all the beams has been created. So now select the slab for this model, modify the slab. Here you can modify them as a S1, 120 mm. Okay, select one story, then this is the top story, so assign the slab here. So 5.4 is the top story, so slab has been assigned. So now select the floor, assign the load as well. So we will not recommend the any international book codes. We will just assign the extra loads that due to high intensity of the load the structure member will be fails. So we want to see fail members of the structure, that we will study and observe the difference between fail members and past members, as well the response response value of the base or base response values of the failed objects and past objects. As well we assigned live load also 3 kilonewton per meter square, and the total we assign dead load, delete the super dead load because we use this we save the user default settings, so the super dead load were was before already saved here, so we delete it because we don't say super dilute here. Save the earthquake load. There is no need for x and y direction because it is just a trial project. It is super dilute is deleted. So now from here you can also click right here, modify and show. So from here you can also enter to this dialog box. So now deselect and select y because we taking in one direction. It is just an example. Our main point is to study the failure parts of the objects, members of the objects of the models. Now define the mass source. You can show and modify mass source. The existing mass you can make a changes in existing uh, mass source. So it is the easy way. So add live load as a 0.25% of the all loads, and live load dead load is 1. Okay, the default system, save the default mass source 1 as a default. Now define also the diaphragm. Diaphragm is very important for wind loads. Select the rigid diaphragm. Okay, mostly for concrete frame structure we will use a rigid diaphragm. Semi-rigid diaphragm also using for steel structure mostly. Select D1. Precast concrete also you can use the semi-rigid. Click right here, show and multiply the wind load as like we selected the earthquake load. Now show and modify them. Select as a 38 meter per second the wind velocity. Site is C. Okay, and okay. So now we will load come towards load combination. So I use concrete frame design as a default setting of the Etab. So okay, now assign the mesh to the floors. Go to assign as shell and mesh option, select the last one. So the mesh is assigned to the mesh is also assigned to the floor. Now go to the zero elevations and select all the joints. Keep in mind that you selected story 1 only. If you select similar story, your diaphragm will be fails and joints, so it will be a warning message if you not select a one story. Select all story and check all the points here. You again I tell you that go to option to save the user default settings. User save default settings. This one is user save default setting. Click here. Message your default setting were successfully updated saved. So that is the way. Now the message has been created that there is no error messages. Our model is check is okay. So now run the analysis. Before run analysis we have to save the model is saving. Now the analysis is in progress, so we will wait once the analysis is completed, so then we will be process further. So now you see that some columns is seem like bent. So now it check in completed. So now we will see verify our member passed. 12 concrete frame failed the design, check. Okay, 12 members means that all the members, here you see that all the beams seems failed. So now we will see the uh, shear force and bending moment diagram of this fails. So check the axial forces. Okay, axial forces, so the load is properly not transferred to the columns, the limit of the load is same, so it is already selected, seems like selected. Film, you see the shear force diagram is also not properly on center point. See, you see that the load is not properly transferred to the foundation. Now see the moment diagram. The moment diagram is not in middle of the column, this cross section, and bending moment diagram with the cross sectional shows us this is the load direction to from x to clockwise towards z directions, means z elevations, mm2 and mm3 is very important for us. It's from x direction or clockwise. So it seems that some of the beam is showing the 0 on the center. So now we will check the story displacement also. Select the case dead load model in. Okay, so displacement is in 90 degree, so it's okay. Displacement is okay, it is 90 degree. Maybe the displacement will be not according to the international codes. So but we just to find and see the shear force and bending moment diagram, and also we'll understand that how we can change. This is the base reaction tabulated form. So the base reaction, it is okay because it is 204 and 78.5 and not the, it is variable. So the column is okay for, see, likes the column is okay. If the load transfer is successful and the beam has passed, then maybe some columns fail the design check. So now we how to this right click on this beam. After design check, you right click on these beams, verify the 12 continuous. So right click here and go to the P1 200 by 300, so override and click current design section, select the B2 200 by 500 and OK. OK, now you will see the one beam is resized. So now C3, we selected C3 for this beam, B3 for this beam. So right click here, override and select the C2. OK and OK. Now for this beam, right click, see it is C2, we select the beam is a B2. Okay. So if you now you are seeing that anyone the selected by the Etab, the fail members, click right click and do the same. So now how much the concrete members will remaining fail. You can also go to detail. Here is the detail of each beam and each column. Summary. Now we are it is the summary of the column element detail summary. Now click on shear stress. So this is the shear stress summary is here, and flexure detail, shear detail, joint shear details, and all the details are here left side of the bar, so you can see each of them. And okay, so now how much is remaining? 1 2 3 4 and 5 members are still remaining, so we check the verify. 6 members, 1 2 3 4 5 6 6 members remaining fail, so click here overwrite. It is detail of, see here you see the detail of fail members as well. After that you check with the past members, so you will understand that why this beam or this column is failed by the Etab. So select the B2 or B1 is already failed, so we select B2. Okay and okay. Now how much the remaining is? 1 2 3 4 and 5. So now verify all the members are passed. See 5 concrete frame failed to design check. So you can, if you need, we want to pass it, so do the same process, same procedures, apply the same procedures for passing the remaining. So now we check the shear force diagram for these fails, and we will see the difference between the two. So here the shear is failed, so the shear wall is between columns and beams. So here is the, and this is also not a stable, because here is also not, the shear force diagram is not a proper, it is a negative moment. So we should to increase the size of the beams. This size, the members has been passed, but currently the size are not according to international code, so it seems that the shear force diagram is not a proper and stable. So now check the moment diagram as well. The moment diagram is now looking like it is not maximum in center point, so therefore it is not feasible, like seems like not a proper feasible. So go to again and verify and check 5 concrete members are fails. So right click here to see the detail, geometry, assignments, loads and designs. Loads, non-loads, there is no load. Design, rubber concrete frame structure. So now check again, go to verify first members, so the remaining all the concrete frame passed the design check, so it's okay. All the members has been passed by the Etab. Thank you for watching this video. I hope you will understand it.